I was asked to talk about a topic that I'm coming to the tail end of. I've spent probably the last 6-ish years building a lab workspace at home and things like that. So this is how to get started building a bench in a lab and hopefully not tripping down the rabbit hole as far as I did because it got nuts. A little bit about me. Didn't change. There it goes. A little bit about me. I have worked on many different types of systems, which helps out, which is part of the reasons why the lab is this way. I've been a repair tech for 30 years. I worked on large scale power systems, both grid scale and smaller, fiber optic distributed data systems, large and small scale Ethernet networks, animatronics, both hydraulics and pneumatics, and industrial food processing, non-food, 70mm projectors, and I've also done live sound and mixing for theaters. So it's been a wild ride. The lab itself didn't actually fit on one camera, so the bench starts at the top and it's right center. And part of the reasons for the three pictures is my camera did not have a wide enough lens to get it all in one shot. Current lab specifications. Sorry. Just a little bit. It's for DC, I go from 10 nanovolts to 1600 volts. Current is picoamps to amps. AC voltage goes up to 1500 volts. And resistance is micro ohms to tera ohms. And then frequency is running about 10 microhertz to about 3 gigahertz. I go a little bit over 3 gigahertz up to 18.5 in some places, but I'm pretty solid up to 3. Over that gets a little dicey. I do have a full set of calibration standards available. Get into that in a little bit. That was driven by necessity and not having anything available. So part of the reasons for that, or the difference between a bench and a lab, benches tend to be a single table, maybe a table and some shelves. Labs usually upscale to a room, have considerations for power, water, compressed air, and RF shielding in some cases. There are places where I helped somebody paint the walls with an RF shielding paint, and then he was very surprised that his cell phone didn't work in a room anymore. So a lot can be done, and in certain places, the RF shielding is critically important. I know in one of GE's Cal labs, they do all their 7.5 digit plus measurements in a Faraday cage, specifically for that reason. Ways to get equipment, build, buy, and fix. There is some custom built stuff that comes in catalogs, things like that, great little projects. Obviously buying new and then fixing things from secondary markets. Where to find a couple of the vendors I use for new equipment. Valuetronics, they have a pretty neat discount deal where I think it's 5% of whatever you spend goes into store credit, and you can cycle that back into next gear you need. Teequipment.net, they have another deal where if you're a member of a very large EE blog, there's a discount there. Direct from manufacturer. That sometimes gets a little dicey depending on what you're ordering, especially some of the bigger test equipment houses, HP, Tech, Fluke. For some of the gear, they will not sell direct to a customer. You have to have a business. Not 100% sure why, but and there's certain stuff that they get really picky about that. Some of the test equipment that's available to us here in the US is ITAR regulated. Two things that come to mind is fast edge pulses and thermal imaging cameras. You actually cannot export a thermal imaging camera that does better than 9 hertz refresh rate out of the US. Secondary market, eBay estate sales, closing labs. Those tend to be larger pickups, and usually they will not ship anything. You have to go get it. Government auctions are the same way. You'll probably bid on a pallet, and if you are the winning bid, they will want it gone in 24 hours. Equipment that was bought from the lab, a couple of things. We have a couple of power supplies, a meter, some function generators, which were bought for a specific video, and a frequency counter. Everything else on the bench was sourced secondary market, and lots more red arrows on the next slide, which was sourced from various places secondary. Equipment that needed to be repaired from the secondary market, 3 arrows go away. So probably 95% of the stuff that I've sourced has not been up to manufacturer spec in one way or another. It's needed some form of repair work, calibration, alignment, tuning to get it up and functioning and ready to go. Some of the things are also, I go all the way back to tube era to present. So especially with some of the tube era stuff, the caps are starting to show their age, things like that. They do need to be refreshed. Different types of benches: basic repair, advanced repair, audio labs, RF labs, calibration labs, and then very specialty use exotic gear. For basic repair, it's actually not very complicated. DMM, power supply, and soldering iron. So that's really all it takes. DMMs, there's some choices there. Handhelds or versus benchtop. Both have their advantages, some have their disadvantages. Handhelds, portables with batteries, they will probably not be on the bench when you need them. You'll have to go find them. Also, they have a accuracy ceiling. I have not found many handheld DMMs higher than 4.5 digits. So more accuracy in the bench tops, and then for handhelds, they go to sleep. With the mains powered meters, they don't go to sleep and they'll stay on as long as you leave them on. That's actually really important at some of the higher accuracies. Some of the warm-up times are 1.5 to 3 days, depending on what the device is. And then the other thing is we only have up to 8.5 digits on a multimeter. More accuracy than that, and it doesn't exist. Power supplies for consideration. How much power do you actually need? Usually far less than is specified. An amp is plenty. There are certain situations where you'll need to go over that, but for basic repair, circuit design, things like that, 1 amp's fine. Linear switching is fine. Linear, you can tell by picking them up. Linear power supplies are a lot heavier than switching power supplies. They are a little more quiet though. So from the DC output, they don't put out as much noise and tend to be a little more stable. Accuracy too can be a thing depending on what you're working on. A lot of the older power supplies will have needles, which will get pretty close. Some of the new modern stuff, especially with deep sleep circuits, things like that, stuff that goes into consumer gear, you'll need to measure microamps, and then it'll jump up to milliamps when it wakes up with the microcontrollers, and higher accuracy is needed than a needle. They got to react faster. A needle meter wouldn't be enough. Outputs, most of the time, you'll get single, double, or triple. Now, what's weird on a triple is you'll have 2 outputs that are fully functioned and then one that's kind of halfway. So on, for example, this Power Designs, I've got 2 25-volt plus minus supplies, which are great for op amps, things like that. But the other supply only goes up to 6 volts. So I've got a plus minus 25 or plus 25, depending on how I have it configured. And then the third one's kind of there and never hooked up. A note about charging batteries. One of the things that I use power supplies for a lot is charging batteries on the bench, especially with lithium-ion batteries. You have to be extremely careful with that. Lithium-ion batteries, especially if you're charging the cell naked, they can explode. They will cause a fireball. It will not be a good day. The other thing is with some of the higher modern power supplies where you can turn the output off, they do not like reverse power on the outputs. I've burned up the output of a very expensive power supply by hooking the battery up to it with the output off. Cheaper one up at the top, it's always on. Charge batteries great, doesn't care, but you can't turn the output off. So just some things to think about. Soldering irons, any good brand soldering iron, pick your brand. Paco, Pace, JBC, Medcal. Weller does make the list. However, if you have one of the blue boxes from Weller, for whatever reason, they took the mains fuse out of the power transformer. So they have been known to burn up power transformers before. That typically happens less here than it does overseas, where they have 240 volt. But I don't know why they pulled the mains fuse out of the power transformer, but they did. The older style, which has a ceramic heater that the tip goes over, similar to the Haco 888 or 888D, they're still good irons. They're not too bad. The newer style, which has the integrated tips, are really good. I traded out all the old ceramic style stuff that I had, the newer style ones. They heat the pads, it doesn't care. I use a small tip on a giant pad, it doesn't care, it just does it. I did bring some if anybody's curious to see. I have some sampling equipment from all price points that I brought in. The other thing is chisel tip. Having a chisel tip, even a small chisel tip, actually does better than the conical tips from what I've found. That's personal preference. Soldering's half art. It just works better for me. On the extreme end of soldering, you can actually get into nitrogen soldering, where you have a nitrogen gas flush system. Hot nitrogen goes over the tip into the joint. It does work. It's nice. It is ludicrously expensive.
Do you do surface mount work?
Yes, I do. So micro tip for surface mount and drag soldering right now. One place where I am lacking and I do need to fix like yesterday is I don't have a hot air gun. The other thing that I'm really looking for a good pair of that I don't have quite yet is hot tweezers. I have some 2000 series scopes that need a whole bunch of surface mount caps swapped out. Hot tweezer is actually two irons in one assembly where you just touch the part and it just pulls off as one unit. I tried one, the older Paco style. The tweezers flipped and never lined up right, and it was not a good experience. One thing to note on the Metcals, they're an RF iron. So if you want to change the tip on a Metcal, you actually have to, or change the temperature on a Metcal, you actually have to change the tip. On the Hagos, the Pace, the JVCs, you set the temperature on the iron, it hits that, it's got a temperature sensor molded into the heater, and it is highly accurate. Calibrating the irons, I found it to be off about 5 degrees C from the set point from the factory. So not bad. Good solder too. Kester, Loctite, MG Chemicals, good solder will change. If you're struggling with soldering, good iron, good solder, you won't have a problem again. Advanced repair, adding a scope to the mix. Nowadays, with today's prices, if you're looking for a digital scope, it's something minimum 100 megahertz, 4 channels. The price can go up from there. 500 megahertz is a good place for 10x probes. Anything over 500 megahertz, you start getting capacitive reactance, and the 10x probes start being a problem, and you need to flip over to active probes, which will need 50 ohm inputs. So there is some stuff that I have that's above 500, but really above 500, it goes into transmission line as opposed to passive probes. Function generators to a reasonable specification. Some of the older HP boat anchors in the picture, these 8904s, if you're going to align an FM radio, there's a certain configuration where they will do the FM stereo modulation. You need an RF source to be modulated, but they'll actually set up the left-right stereo and to do an FM alignment on a radio. The Rigel in the picture, it's a 100 megahertz function generator. That was bought at the request of, can you use a function generator to calibrate an oscilloscope if you buy one from eBay? You can get close. The real challenge there is the high frequency compensation of the vertical amplifier, which you'll need a signal with an edge on a 5 gigahertz speed. So you can get about 90% with a modern function generator. To add audio, pretty much low distortion sources. A couple of examples, SG505 with a automatic distortion analyzer. Probably the Tech AA501 or 5001 would be the one I would target if you were looking for the old side of the fence. The HP stuff is not automatic. The notch filter on the Tech is automatic. Plug it in, it does its thing, you get a distortion measurement. The HP version you have to tune, and it's kind of cumbersome to use. Something that's newer, which is absolutely phenomenal, is the Quantasylum. It's audio spectral analysis, and it's 0.0001% HD. The specs are incredible for the price. It's not cheap, but it's not audio precision either. The Quantasylum can measure directly the distortion of an SG505. Getting below 0.005% THD is getting hard, regardless of what age, what time, and what budget. We're really getting into the bottom of the noise there. An RF lab, where it gets fun, is RF signal sources. Very similar to the HP over there. One of the things that's good about RF signal sources is the low output. A function generator usually cannot get low enough, even if the frequency range is useful. To tune a AM receiver, FM receiver, you have to put 7 microvolts on the lead that wraps around the antenna. So one of the ways you do it is you take the antenna, wrap the lead coming off the RF source, and then you need 7 microvolts on that line. There's not a lot of gear that does that. It's special made. The RF signal source only outputs at the high end 2 volts. So it's not going to scream in anything, but it's also safe to put right in the front end of a receiver to align and calibrate it. High-speed scopes, spectrum analyzers, frequency counters. The HP 410B that's in the picture, that's actually a needle meter that can read up to 700 megahertz. Really, really hard to do on the analog side of the fence. They have a 1 gigahertz diode in the probe tip that rectifies the DC to go into the meter. That's how they get the high speed. And it's the only needle meter that goes that fast. Calibration labs. This is where stuff gets horrifically expensive. Some of these boxes, all of these boxes were used. I even bought the AC ones broken. Got them from the US Air Force for, it was 3 figures broken, almost 4 figures broken. And there's still nothing less than 20K that can replace it. Typically too, with calibration gear, this is where the stuff gets plugged in, turned on, and never turned off. Thermal hysteresis on the reference diodes is enough to throw them off. So all of this stuff, except for the resistance standard, had to come in secondary market, and I had to fix it. Still working on calibrating it, and it's one of the reasons why I needed the 7.5 digit meter, because I had to get truth somewhere. If I don't know where to start, I don't know where I'm at. So hence the 7.5. I really need an 8.5. Not yet. Exotic equipment. In this picture, I have a curve tracer. One of the things that is for modern gear is a battery simulator. It's just a fancy power supply. It can take an amp, so it can actually act as a battery without using a battery. So it can take a charge current, act like it's charging up. It can then discharge, act like it's discharging. Kind of a neat feature. I've used it once or twice. Source measuring unit is one of the other odd ones. It's a very, very precise, perfect current source within its power band. So if you ask it to put out a milliamp, it'll drive to 200 volts to try to put out a milliamp. So it can measure resistances, extremely high resistances, very, very accurately. That's the one device that gets me into the tera ohm. It will literally measure the resistance of the plastic banana jacks when you put it into the outputs. And there's actually 3 units on that one. I have the general purpose unit. There is a high power and high voltage unit as well. High power goes to 6 amps, high voltage goes to 1,000 volts. Curve tracers, it's a fancy VI plotter. I have needed it every once in a while, needed it to fix the 5200A. It's there was some transistor leakage, which was why the negative 190 volt rail burned down. The leakage didn't show up till close to rated voltage. So on a low voltage tester, it would test fine. Push it to 300 volts where it was close to breakdown, and then it would show the leakage and actually showed why the part failed. Conclusions or questions? Labs can be purpose-built. They also evolve over time, and there is no one size fits all. So every space is different. That's a little bit of what mine looks like. So I did bring kind of a sampling of some here. I did bring a curve tracer if anybody hasn't seen one before. So I guess during break we'll have a table out.
All right, any questions for Eric?
Yeah.
In the back.
Kind of, you need to keep this equipment running in case of voltage fluctuations.
I don't. I should.
Okay.
I have some small UPSs. There's very specific gear, frequency standard, a couple of things that are on some small lever units. Realistically, we're designing a place where we might have, we're thinking about designing a place purpose built. It'll cover the whole 80 amps the lab needs. There's behind the bench, there's 80 amps in the wall. There's 420 amp circuits. They don't run that all the time. I don't want that power bill. Yeah.
On the probe for the meter, the 700 megahertz frequency meter, what kind of technology or solid state is in that rectifier that's out of the tip probe?
Nothing. It's a capacitor into a vacuum tube.
Oh,
Yeah.
okay, so it's not gallium or anything.
Nope, it's a vacuum diode.
Do they run, what voltage do they run that at?
6, actually it depends on which version. So there's 2 different versions of the 410B. And there's 2 different diodes that went in there. They're not interchangeable. The earlier one was like 5.5. The later one was 6.5. Yeah.
Now that you've built your lab, are you going to Disneyland or
Yeah.
what are you gonna be doing?
Well, I gotta clean the garage out now. I do have, and if anybody needs any equipment, let me know. We picked up 7,000 pounds of test equipment from Santa Fe last year. And there's a bunch in there. So if anybody's looking for scopes or anything like that, yeah, it's vintage, yeah, it's CRT, but I have probably 9 7104s, 7103s, which are the 1 gigahertz scopes from Tech. Most of the stuff came from Los Alamos.
I was gonna say, does it glow or?
I thought about, I may have needed a Geiger counter on some of the stuff, but no, I got stuff with NASA stickers on it. I got stuff from the Air Force. It's coming from everywhere.
Any other questions? If you're online, you're welcome to unmute too and ask questions.
I do have a question online. I'm assuming, Eric, number one, thank you for this great presentation. I'm assuming this is not just all part of ham radio for you, right? I'm assuming there's, this part of this is, or a lot of this is profession and whatnot.
Sort of. So by profession, I'm a computer network engineer. But no, what ultimately started this was I even brought the scope today. There was I tripped down the rabbit hole really, really hard. What started this was I had a power supply soldering iron and a blue 179, which is all I had. And I started a class. Actually, I started Mr. Carlson's class for a variety of reasons, one of which I was bored and in a funk. But to do that, I said, well, I need a scope. And I found a Tech 485 scope, which is a 350 megahertz 2-channel portable scope in the 400 series. It's the top end of the 400 series. And I got it in, started doing some testing on it, found it to be marginal. I was like, okay, well, if I'm going to use it, I want it to be meet factory spec and calibrated. And that's what tripped me down the rabbit hole was I said I was going to calibrate an analog scope. And I didn't know what I was getting into at that time, but led me down the path of getting the calibration tools. Then I had to validate the calibration tools. And that's when I needed to buy the 7.5 digit meter. And then so I fell down and then climbed back out, which is how everything got started. And it was partly necessity too. So I did call Tech and asked them, I said, okay, can I send this to you and get it calibrated? And they said, yeah, it's $100 for a 465, which is the 100 megahertz version. I'm like, okay, that's not too bad. And I was like, okay, how about a 485? And they go, well, it's $899. So it's $899 for the calibration, but you have to send them a fully working scope to calibrate. So if it doesn't calibrate, they'll just send it back uncalibrated. They won't fix it for you and then send it back. They'll just say, hey, it didn't meet spec. Sorry about your luck. There went $800. So it was spooling up. The other problem was I got pretty deep into the 7000 series. And one of my favorite scopes being the 7603. Nice big screen, great for presenting. Well, that has a frame and then plug-in modules. It was $899 to calibrate the frame, $899 to calibrate the plugins each. So to do one of those scopes front to back, it was 4x $899. So at those numbers, getting the Cal Lab, especially with some of the prices I was finding this stuff, started to make sense. The Scope Cal plugins, I think I picked them all three of them up for like $250. And once they were validated, I just keep using them to fix the stuff. So what then ended up happening was 2020 came around and I got bored and decided to start a YouTube channel. And that has kind of taken off and gone a little nuts. We're about to break 4,000 subscribers on the YouTube channel. And the response has been way more than I could have ever imagined.
What's the name of the channel?
Zen Wizard Studios, ZenWizard.
Yeah. Any other questions for Eric?
Yeah, I got one.
All right.
Kind of a bigger picture. Again, thanks for doing it. And some of the stuff you're talking about is probably way above my head. But infrastructure-wise, you mentioned that the 80 amps that you need just to power up your room there. What about fire protection, detection, and HVAC? Did you have to modify your space in any way for those kind of considerations?
No, so infrastructure-wise, there's so I soundproofed everything because of the recording, and that caused me a little bit of trouble because the space I used rock wool, which was used to be Rockwell. I think they're Ruxel now, but the product was called Safe and Sound. That's spun rock wool and metal slag. Well, with metal slag in there, it kind of nukes the Wi-Fi. So I did have to do some stuff with Wi-Fi, and any recording studio with audio considerations, there's so much foam on the wall. It's a borderline refrigerator, so it needs cooling for HVAC. There's a small 1200 BTU unit that exhausts outside. Chews up a lot of makeup air. Not the greatest solution. A mini split would be much better, but when I was putting everything in, mini splits weren't really a thing. 80 amps is the available power. It does not chew up that much power continuously, thankfully, or my wife would shoot me for the electric bill or for other reasons. However, the HP stuff, anything with crystals in it, they like to keep the crystals hot. One of my fellow YouTubers who has a bigger lab than I do, Shariard from the Signal Path, actually measured it. He had a whole bunch of HP gear. He was burning a kilowatt continuous in standby just to keep the ovens warm. So, and I did bring one of the time mark generators from Tech, one of the old ones. That's one of the biggest offenders. Is it has I think it's 150 degrees C oven, and it burns that. If it's plugged in, it's cycling the oven just to keep it warm. Now it's a 3-day warm up if the crystal's cold for stability. If the crystal's warm, it's a 30-minute warm up for the device. You just turn it on, wait 30 minutes, and it's ready to go. So, but that's more on the frequency side of the fence than anything. So turns out frequency stability is actually really, really hard. For the lab, we have frequency standard in the lab. I am on rubidium, and I have a GPSDO that's doing 1 pulse per second into a rubidium standard. So I'm down to 10 to the negative 13th for frequency accuracy.
Any other questions?
Obviously, you've got a fortune invested. Are you doing any kind of service work or anything like that to help recoup some of that?
I do sell some gear every once in a while, and I do fix and repair things. So especially from the calibration side of the fence, don't dive down the rabbit hole. You guys know me. Let me know. I can help out. The cal gear is where it gets really, really stupid, and you need that once, maybe twice. But yeah, we can work something out. YouTube is not making money, so Google is paying me at this point, but it's not a ton. But the response has been crazy. Somebody sent me a TG501 from Sydney, Australia, and I told the guy, because he was going to send it to me, and I said, "There's got to be somebody closer than Fairfield, Ohio, to Sydney, Australia, to get this thing fixed." And he goes, "Nope, it's going to you." Okay. So, yeah, it's been wild. I've done stuff all over.
How long did it take?
Well, that was the goofy part. It took like 3 days for me to get it.
Oh my God.
It took him 3 weeks to get it back. It sat in Florida for 3 weeks before it went. It went out, so it came a lot quicker than it went. One of the wild ones that somebody found me through YouTube, and I just got finished working on, actually it shipped back Monday, was I did a restoration on a Tektronix FG506, which was an engineering prototype that was never made. There's only 2 in the world, and they sent it to me to get it fixed. I still don't know why.
Eric, outside of your YouTube, do you have a website also?
Yeah, ZenWizardStudios.com.
Anything else for Eric? All right. Well, thank you, Eric.